Welcome to analyzing a binary variable about the effect size Cohen's G. The example I used in my previous video was about gender, where people could choose between male and female, and 12 people identified as male and 34 as female, which boils down to 26% versus 74%. Now, we already did a video on the one sample binomial test, and from there we could conclude that those two percentages are indeed significantly different from each other. So probably in the population there will also be a difference in percentage between male and female, so it won't be 50-50. Now in this video we're going to determine if this is going to be considered a small, medium or large difference, which we can do by using a so-called effect size. There are a few different effect size measures that can be used for a one sample binomial test. I'll be using information gathered from Rosno and Rosenthal, who published an article in which they actually state that a dichotomous, not really sure how you pronounce that, which is the same as a binary. So if you have a one sample data binary, they recommend Cohen's G, Cohen's H, or an index or a new index called capital Pi. I've chosen to use Cohen's G. There is a small but big warning for Cohen's G because it's only applicable if your assumption is that in the population the percentages are 50-50 or the chance is 0.5. which was the case in my example. If you're interested in a video on Cohen's H, let me know in the comments below and I might actually make one, but this video focuses on Cohen's G. Now, Cohen's G was of course created by Mr. Cohen, Jacob Cohen himself. He wrote a book called Statistical Power Analysis for the Behavioral Sciences, and in this book on page 147 he describes the effect size index G, and as you can see it's actually not that difficult. It's simply the proportion that you have in your sample and then you subtract simply from that the 0.5. So in essence this tells you how much of a difference it was of 0.5. Now, the nice thing is that he also gives some rules of thumb. These are not set in stone. They can vary a lot by field of study, but it's always nice to have somewhere at least someone giving you a little bit of help on rules of thumb. He defines a small effect size as G is 0.05. A medium effect size of 0.15 and a large effect size of 0.25. Note, by the way, that the maximum can be 0.5. So if you have like 100% versus 0%, then the middle one is 0.5. So you have your maximum difference of 0.5. Now, one small complication here is that what about those values in between? And I'm guessing here that since this is a large effect size of 0.25 and it can be higher, so anything 0.25 or higher would be considered large. So therefore anything between 0.15 and 0.25 would be considered medium. Anything between 0.05 and that 0.15 would then be considered small, and anything below probably negligible. And therefore I created this small table, which I think is pretty much okay as a first starting point for your interpretation. Again, these are just rules of thumb. Also, Mr. Jacob Cohen himself mentioned this a few times, that this is just one rule of thumb and it can heavily vary per situation, per field, etc. Now this video won't be about how to actually calculate Cohen's G, although it's pretty straightforward. But you can use SPSS, for example, or you can use software like R Studio, or you can use even Excel to simply calculate this. Or you can do it by hand, fill out the simplistic formula, or you can use some online calculator and that will also give you Cohen's G. So as you can see, all of these result in the same values. Some have a minus sign in front of it, depending on how you actually define Cohen's G. but usually it's the undirectional one that is of importance, which basically means to ignore any negative signs if you have them. All of these options, I have instructional videos for those on my website. So how to do it by with SPSS or with R or with Excel. Simply go to peterstatistics.com, and then on the top you have to select somewhere here one variable. You get a pull down menu there, and then select a binary variable. Then select in the left menu effect size. Then you should be getting to this page, and it will say something here. Click here to see how. And then if you click on any of these options, any of these options that are here below, which are the options that are mentioned here above, so SPSS, R, Excel, manually, or the online calculator. My website might change, of course, in the future, but perhaps it gets expanded. But if you're interested in any of these, there are videos on how to obtain this value one by one. The last thing is to add Cohen's G to our report. So we determined Cohen's G in the example was 0.24. And looking at our interpretation table, that would be sitting just still in the medium category. So we already had with our one binomial test that it was significantly different. And now we simply add to that Cohen's G suggests that the difference can be classified as medium, and then G equals 0.24. That was it. I hope you enjoyed this video, found it helpful. If so, please subscribe. That really helps. Or like, or if you have any comments or questions, let me know in the comments section below. Thank you for watching.